Directions are graph y equals 2 log base 3 of negative x plus 4 plus 1. So the first thing we're going to do is we're going to look at the basic graph of y equals log base 3 of x. And then we're going to do each of the transformations. So we'll do this transformation, which will be an up 1. We'll do this transformation, which will be a left 4. We'll do this transformation, which will be a reflect on the x-axis, and we'll do this transformation, which will be a stretch by a factor of 2. So first, we notice that this can be written as 3 to the y equals x. And you make a little t-chart. You can see that if you plug in 0 for y, you get 1. Plug in 1, you get 3. Plug in negative 1, and you get 1/3. And then the graph of that will look like this: 1 comma 0, 3 comma 1, and 1/3 comma negative 1. So that's our basic graph. And then what we're going to do is transformations to that graph. The first transformation we're going to do is moving the graph up 1. So now what we'll do is we'll graph the line, or the curve, y equals log base 3 of x plus 1. So that's pretty much the same curve, except instead of having the point 0 or 1 comma 0, I have the point 1 comma 1. So everything just got shifted up 1. So then let's look at the next transformation. And what we're going to do is remove the graph left 4. So now we're going to graph y equals log base 3 of x plus 4 plus 1. And that graph still has an asymptote at 0, but now instead of having the point 1, 1, it has the point, let's see, left 4. So 1, 2, 3, 4. We have an asymptote here. So I lied, it doesn't have the asymptote at 0, it has it at -4 because I just went left 4 with this transformation. And then the graph comes up and curves like that. Not perfect, but it's alright, you got the idea. Okay, then we have the transformation where we're going to reflect over the x-axis. So let's move this stuff out of the way. Okay, so now that asymptote was on the left at x equals -4, but now because we reflected, picture this as an axis right here, and you're flipping this around on the on the y-axis. So now the asymptote lives right here. And remember, before it was going off to the right, so to reflect that now, it's going to go off to the left, like that. And then the last transformation is to just stretch this out a little bit by a factor of 2. And that doesn't hugely change the graph, so I'll just put it right here, stretch by 2. So what we see is still the same asymptote here, the dotted line, but the curve kind of goes a little bit faster, a little bit steeper. Okay, so then let's move that all the way up. And then, so here's our graph. 2, 3, 4. Something like that. That's not a perfect graph, but here, let me take that off. Okay, let's try it again. This actually should come down. There we go. That's a little bit better. Okay, and that's the graph y equals stretch by 2 log base 3 reflect over the x-axis, left 4, and up 1. So we see the domain, that's how much the graph goes left to right, and we see this graph goes infinitely to the left and then comes up to positive 4 but doesn't touch it. And the range is how much the graph goes up and down, which this graph goes infinitely down and then infinitely down, infinitely up, sorry. And then let's see, we still need to do the intercepts. So let's see, an x-intercept. What we're going to do is set y equal to 0 and solve. So when we do that, we have 0 equals 2 log base 3 of negative x plus 4 plus 1. So we'll subtract the 1 and divide the 2. So on the left-hand side, we have negative 1/2, and on the right-hand side, we have log base 3 of negative x plus 4. Let me move this up. And then we rewrite this in exponential form, and you get 3 to the negative 1/2 is equal to, negative x plus 4. And then this is really 1 over 3 to the 1/2 equal to negative x plus 4, but that's really 1 over the square root of 3. At the same time, I'll subtract the 4. And then let's move the screen up. Oops, gosh dang it. Then we're going to divide everything by negative 1, and we get x equals positive 4 minus 1 over the square root of 3. And then plug that into your calculator just for a decimal check, and what you get is it's about 3.4. And that's right, because if you remember, the graph looked like this, and it came down, so that's probably about right. So we can see right here, that was about 3.4. So we're fine with that. Okay, then let's do the y-intercept. And that is set x equal to 0 and solve. So we get y is equal to 2 log base 3 of 0 plus 4 plus 1, which is y is equal to log base 3 of 4 plus 1. And then this is a little bit harder to check as a decimal because we can't do log base 3 on the calculator, but you can just switch this to a base 10 problem to check it. So the change of base formula says you take the log of the 4 divided by the log of the 3, and then now those are base 10s. So then you plug that number into your calculator and you get about 3.5. And then let's move the screen up. So really then if you look at the graph one more time, 1, 2, 3, 4, and there's your asymptote, and it came down like this, and that value that we were checking was right about here, and it looks, I mean, it could be about 3.5, I'm not 100% sure, but it looks pretty good. So there you have it. That's the graph of y equals 2 times log base 3 of negative x plus 4 and then plus 1. There you go.